Okay, let's take a look at something called selective precipitation. It's a fancy term that means different compounds have different KSPs. And what that means for us is that you can add one common ion to multiple compounds that have the same ion but different KSPs and get one to precipitate out and leave the other. Let's take an example here. It says here, this one, it says consider a solution with a concentration of bromine or bromide ion that's 1 molar, and the concentration of iodide is 1 times 10 to the negative fifth molar. You slowly add a solution of AgNO3, and what solid will precipitate first? AgBr, silver 1 bromide, or AgI, silver 1 iodide. Let's get some KSPs for these guys. The KSP for AgBr is 7.7 times 10 to the negative 13th. And for AgI, it is 1.5 times 10 to the negative 16. Now these vary depending on what source you use, so be careful. Now obviously, all things being equal, the silver bromide will precipitate out at the silver iodide will precipitate out at a much smaller concentration, 3 orders of magnitude smaller than the silver bromide. But we're also talking about different solutions here. So let's calculate the concentration of silver required to get each of these to precipitation. Let's do our silver bromide first. So if we know that silver bromide has a KSP of 7.7 times 10 to the negative 13th, and that the equilibrium expression is going to be a silver and bromine. According to this, we're starting with 1 molar. And obviously that makes the math real easy because check it out. 7.7 times 10 to the minus 13, and of course we're going to approximate. We'll just make this X. And this is 1 molar, so you don't even need the math. What this means is that X is the concentration that you got to get to in the silver ion concentration to get this to precipitate. Hang on, let me get this thing out of the way here so we're not too distracted. All right, you don't even need a calculator for this one. I mean, this guy is 1. You don't even need a calculator. So that means that the silver bromide will precipitate out when the concentration of silver in solution reaches 7.7 times 10 to the negative 13th molar. How's that going to compare with our silver iodide? Well, our silver iodide has a much smaller KSP. KSP is equal to 1.5 times 10 to the negative 16th. And of course, that's equal to the concentration of silver times the concentration of iodine. But check this out. We're already starting with 1 times 10 to the negative fifth molar iodine. So what concentration of our silver does this need to get to? So let's plug this in. This is 1.5 times 10 to the negative 16th. This is going to be equal to X. That's our silver. The iodine, 1 times 10 to the negative fifth. You probably don't need a calculator for this one either, but it's always a good idea to have one. And this is the concentration of silver that you need to get the silver iodide to precipitate out. 1.5 times 10 to the negative 16th divided by 1 times 10 to the negative fifth. And this is 1.5 times 10 to the minus 11th molar. That means that the silver bromide will precipitate first. So when this question asks which one's going to fall out of solution first, you only have to get the concentration of silver to 7.7 times 10 to the minus 13th in this situation to get the silver to precipitate. Whereas you have to bring the concentration of silver all the way up to 1.5 times 10 to the negative 11th molar to get the silver iodide to precipitate out. So a good example of a question we might expect to see. Let's crank this up a notch. I found this monster. And this one's pretty ugly, but the questions kind of answer themselves. And we'll discuss what's going on with the last one, the last part. But it says silver ion is added to a solution that contains 0.01 molar chloride and 0.01 molar iodide solution. What salt precipitates first? This is really similar to what we just did. Let's do that part first. A. Which salt precipitates first? Now, we could answer this question two ways. And obviously, these ions are identical in concentration. And I didn't mean to cross that out, and my trying to erase it won't let me, but those are identical concentrations. So we could plug them in and get the concentration of silver necessary to get there, to get it to precipitate, but you could also just compare the KSPs. This one's a lot bigger than this one, meaning the one that has the smaller KSP means you don't have to add as much to get it to precipitate out. So we could predict theoretically that the silver iodide is going to precipitate first. So I'm going to bet it's going to be that guy. Let's do some calculations just to verify this, and I think we're going to find that when we do this, we'll have answered the next question. What is the value of the concentration of silver ion when the first salt starts to precipitate? In other words, what's the concentration you got to get it to? So let's do the silver chloride first. We know it's got a KSP 1.6 times 10 to the negative 10th. This is going to be equal to the concentration of silver and the concentration of chloride. And there's no coefficients or anything like that. Well, we're already starting with 0.1 molar. So we're just going to say 1.6 times 10 to the minus 10th equals X. That's our concentration of silver, and our chloride is 0.1 molar. So I don't know if you need a calculator for that one, but it's the same as multiplying by 100. So X, our concentration of silver, to get the silver chloride to precipitate is 1.6 times 10 to the negative 8 molar. Let's do the same thing with our silver iodide. In other words, what's the concentration of silver that we need to add to get our silver iodide to precipitate out? Well, we know the KSP is equal to 1.5 times 10 to the negative 16th, and the expression looks like this. Well, we're already starting with 0.1 molar iodines right up there, so let's throw this in here. We're going to say 1.5 times 10 to the negative 16th equals X. And the concentration of iodine is 0.01 molar. So X, which equals the concentration of silver you have to add, is going to be 1.5 times 10 to the negative 14. So which one's going to precipitate out first? Clearly this guy, because you don't have to add as much silver. Does that meet with our prediction? Well, I circled this dude. I said that's going to come out first. So that's pretty cool. We just calculated the concentration of silver to get each of these to precipitate, and we used that answer to predict which is going to come out first. We also answered the second question. We answered this part that says, what is the concentration of silver when the first salt starts to precipitate? We already did that. That's this guy. The silver is going to be 1.5 times 10 to the negative 14. Now let's look at this last question. This isn't something that we're going to typically see, but it's here, and I thought we'd take a stab at it. So, what is the concentration of the anion of the first precipitate? That's our silver iodide, and the anion is, of course, iodine. When the second precipitate starts to form? Well, it starts to form when silver is 1.6 times 10 to the negative 8. So here's what I thought we'd do. And if you feel you want to do this again, or if you have another suggestion, let me know. So here's what I did. We said the second precipitate is silver chloride. It's got a KSP of 1.6 times 10 to the negative 10th. Let me flip those around. So we're going to say, my computer erases really slow. Come on. Last one. You can do it, buddy. Come on. Almost there. There we go. So let's say that for AgCl, the KSP equals 1.6 times 10 to the negative 10th. and this is silver and chloride ion. So we're asking, what's the concentration of the first precipitate? So actually, when the second one starts to form, actually we already know this one. So let's get rid of all this. Let's say that for the second one, AgI, actually that's the first one, we know the KSP is equal to 1.5 times 10 to the negative 16th, and that's equal to silver and iodine. Well, we already know that you have to add 1.6 times 10 to the negative 8 moles of silver to get the second one to precipitate. So what's that going to do to our concentration of iodine? Now, we already have 0.1 molar. It's up there somewhere. My computer's really slow. So let's find what this concentration of iodine is going to be when we get that silver to the point where the second one precipitates. So this is going to be 1.5 times 10 to the minus 16th equals, this is going to be the concentration when it starts to precipitate out, 1.6 times 10 to the negative 8th. And we'll just treat the iodine as X, and then we'll see what happens. So let's solve for X. This is going to be the concentration. Remember that we already had some in there, so let's see what happens. So I get a concentration of iodine that is 1.5 times 10 to the negative 16th divided by 1.6 times 10 to the negative 8 is 9.375 times 10 to the negative 9th. That's going to be our concentration of iodine in solution. Now, there's a couple ways that you could look at it. Is the iodine already 0.01 molar, and we're adding 0.000000, however many zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that going to make a difference? I don't think so. Or is this going to drive the reaction backwards some way? I don't think so, because it precipitates so small. So I just thought we would take a look at this one just together because it's here, but I don't think we're going to take that one this far. So I do want to remind you a couple of things. I'm going to ask you to try a couple of these over the evening, and there's 3 problems I'm going to ask you to look at, and they look like this. And very similar stuff. A solution contains 1 times 10 to the negative 5th molar sodium phosphate. What is the minimum concentration of silver nitrate that would cause the precipitation of silver phosphate? This, be careful here. This one's going to involve some coefficients. Number 57 is going to ask you to compare the order of precipitation. So the least amount of lead ion, the most amount of lead ion. Be careful with number 56. It's not difficult. You're just going to be thinking in terms of pH instead of in terms of concentration of hydroxide. So when it says what pH, all you got to do is find the hydroxide and then use that concentrator to solve for pH. You've done that before. All right, let's take that for a spin. I'll see you guys on the next one.